There's more people waking up to this being a big problem, so we're throwing everything we've got at it to push it out as quickly as possible.
In the 1970s, in the Colombian department of Boyaca, a container was opened and something 2.5 millimeters long walked out into the grass. It was sent to kill venomous snakes. Colombia had thousands of bite cases a year, no way to clear its forests. And this was the plan everyone agreed was sound. The snakes never noticed it arrive. Today that thing is in 4 countries. It has a nickname, and Colombian authorities are still issuing public warnings about it. So, what exactly was let out of that container, and why can nobody put it back? The thing under the log. Colombia's snake problem was never folklore. It was a measured public health burden, with a body count attached. Of the roughly 300 snake species recorded in the country, close to 50 carry venom of medical significance. The annual caseload sits at approximately 5,600 bite events. Colombia's National Institute of Health does not produce polyvalent antivenom as a precaution. It produces it because the demand justifies an entire domestic facility. The geography explains most of it. 3 mountain ranges split the country into 5 natural regions: the Andes, the Pacific, the Caribbean, the Amazon, and the Orinoco. That range of altitude and rainfall and temperature is exactly what produces high snake diversity. Colombia does not have a snake zone. It has snake country almost everywhere, in different flavors. And the risk lands on the same people every time. The World Health Organization classifies snakebite as a neglected tropical disease precisely because of who absorbs it. Rural workers, agricultural laborers, people whose hands and feet go into leaf litter for a living, often hours from anywhere that stocks antivenom. Globally, the disease reaches nearly 2.7 million people a year. The bite is almost never an ambush. It is an accident of proximity, a hand under a log, a step in the wrong place, a snake that was there first and had nowhere to go. Clearing land made it worse in a way that is easy to miss. Cut into forest, and you do not simply delete snake habitat. You manufacture edges, and edges are where encounters happen. Stacked timber makes excellent shelter. Disturbed ground and spilled grain bring rodents, and rodents are the food supply that keeps a viper comfortable near a farmhouse. Snakes pushed out of interior forests turn up around barns and storage sheds. Then somebody reaches for something in the dark. So, remove the snakes. That was always the obvious answer, and it was always unworkable, for reasons that are arithmetic rather than sentimental. Scale is the first wall. Colombia's forested and agricultural land runs to tens of millions of hectares. Snake removal is labor-intensive, site-specific and temporary, because a cleared area surrounded by intact habitat refills. Take vipers off one finca and the neighbors recolonize, usually within a season or 2. You are not draining a pond. You are bailing out a boat that is still in the water. Chemicals were worse. There is no compound that kills a bushmaster and leaves everything else standing. Broad-spectrum poisoning in tropical litter takes the amphibians, the lizards, the invertebrates, and the small mammals that hold the whole system upright. It would also remove the animals eating the rodents. More rodents means better conditions for the snakes you were trying to delete. The strategy contains its own reversal, which left biological control. And it is genuinely important to understand how respectable that idea was in Colombia at the time, because hindsight makes it look reckless in a way it simply did not look then. Colombian applied entomology had wins on the board. Luis Quinchi, one of the founders of the discipline in the country, introduced Aphelinus meli against woolly apple aphid in Boyaca in 1929. He brought in Apantales wasps against cotton bollworm. In 1948, he introduced Rhodolia cardinalis against cottony cushion scale, and that one is cited worldwide as among the cleanest successes in the entire history of the method. These were not cranks. This was a field with a record, operating in the exact region where the ant would later be released. The people who signed off were not ignoring the evidence. They were following it. The evidence was just narrower than they knew. Boyaca, the 1970s. The species was Nylanderia fulva, described by Mayer in 1862, and known for most of the 20th century as Paratrechina fulva, native to east-central South America, the Brazil and Paraguay region. A worker runs about 2.7 millimeters, light reddish-brown, matte, not glossy. It moves in a fast, jerky, unaligned scramble, And that motion is where the Spanish name comes from, hormiga loca, the crazy ant. The Brazilian reference material went back to the early 1940s. It described fulva as a household pest in Brazilian homes, and also as an agent against snakes and against leaf-cutting atta colonies, which it was reported to wreck efficiently. That is the citation trail. Somebody read that a small aggressive ant could destroy atta nests and take snakes, and looked at Colombia, which had both problems at once. The introduction was deliberate. Systematic reviews of South American tramp ant invasions list 4 species that went global, and they single out fulva as the one case where the movement was not accidental cargo in a shipping container, but a chosen candidate for biological control of atta and of snakes. Colombian environmental authorities date the first introduction to the 1970s in Boyaca. The reason the ant looks so promising is the same reason it could never be contained. The two cannot be separated. Nylanderia fulva does not build a colony the way most ants do. It builds many nests with many queens, and in its invaded range, those nests do not fight. Neighboring colonies tolerate each other and merge, producing a continuous population with no internal borders. There is no single nest to find and burn. There is no territorial limit that stops the expansion. The population behaves like one organism spread flat across the ground, and it grows at its edges. It also nests in almost nothing. Leaf litter, rotting wood, piles of organic debris, piles of inorganic debris, rubble at the side of a house, stacked material at the edge of a field. Colombian guidance today still tells rural residents to avoid letting debris accumulate near homes and crops, because debris is the entire requirement. Its diet is where the plan came apart, though nobody could see it yet. Fulva is a sugar specialist that farms other insects. It tends aphids and whiteflies for honeydew, guarding them in exchange for the sugar. It supplements that with protein, taking insects, and feeding on the mucous membranes of vertebrates, both domestic and wild. That last detail is the whole story, and it is worth stopping on. The trait that made this ant look like a snake predator, the willingness to swarm the soft tissue of a vertebrate, is the same trait that would later make it a livestock catastrophe. The mechanism was never specific to snakes. It was specific to anything with eyes, nostrils, and no way to brush the ants off. Around the release sites, forestry and agricultural land was being cut and reworked. Human disturbed landscape is the documented trigger for population explosions in invasive ants across Brazil and Colombia alike, particularly through cocoa and sugarcane monoculture. The ant went into the one condition it thrives in most, and for a while, the colonies did exactly what the plan required. They survived, they established, they spread. From the outside, that looked like success. Subscribing genuinely helps this channel keep making these. Stay for the next part, because that is where anyone finds out whether the snakebite numbers ever moved at all. The numbers that never moved. A biological control program has one test, and surviving is not it. The test is whether the target declines. Fewer venomous snakes in field surveys. Fewer encounters reported by workers. Fewer people arriving at clinics. None of that happened. Colombia's snakebite caseload did not collapse after the 1970s. It is still measured in the thousands every year, still around 5,600 recorded events. And the country still runs a national anti-venom program against roughly 50 medically important species because the demand is still there. The nearly 300 snake species recorded in Colombia are still recorded. Reviews of Colombian snakes discuss habitat and venom, composition and distribution at length, and none of them describes a mid-century predator-driven collapse in venomous snake numbers. Because there was not one. The reason is mechanical, and it was visible in the biology if anyone had modeled it. A swarm of small ants can overwhelm a hatchling reptile under specific conditions. Exposed, immobile, freshly emerged, cornered against something. Hard. Snake reproduction in tropical forest does not hand out many of those conditions. Eggs and neonates sit concealed in burrows, in root cavities, under deep litter, inside termite mounds. In places a foraging column can cross 100 times without ever finding a clutch. Many Colombian vipers are live-bearing, which deletes the vulnerable egg stage entirely. Neonates disperse fast and hide well. And adult snakes are not prey. They are large, mobile, armored in scale, and in the case of the animals actually causing the bites, they are venomous. For the strategy to work, the ants needed to remove enough juveniles every year across enough of the landscape to push the replacement rate below 1. What they could actually do was kill some hatchlings, sometimes, in some places. That is not population control, that is incidental mortality, and snake reproductive output absorbs incidental mortality without noticing it happened. There is a fair objection here, and it deserves saying out loud rather than burying. Nobody ran a controlled trial. There is no clean dataset isolating ant presence against snake density across matched Colombian sites, which means the failure is inferred from the absence of any documented decline rather than proven by design. That is a real gap, but it cuts against the program, not for it. 50 years is a long time for a successful intervention to leave no trace in the epidemiology of the country that ran it. A national anti-venom plant is not what a solved problem looks like. So the ant did not control the snakes. What it did instead is why Colombian environmental corporations were still publishing public advisories about this species in the 2020s. 10 hectares and climbing. Once established, Nylandaria fulva stopped being a forestry experiment and became a landscape event. Human transport did most of the work. Queens and workers nesting in soil, plant material, and stacked goods travel with those goods. That is how the species reached the rest of its range. It is now recorded across multiple Colombian departments, including Córdoba. It reached the Caribbean islands. It was first reported in Panama in 2021 at Boyaca, decades after establishing in Colombia and Costa Rica. In the southern United States, it has become one of the most notorious ants in the region, displacing native species and displacing even Solenopsis invicta, the red imported fire ant, which is itself one of the most aggressive invaders on the planet. Modeling work now treats it as a global invasion risk, with published risk maps for regions it has not reached yet. But the number that gives you the physical sense of it is Colombian. In the literature on chemical control of this species, one reported Colombian infestation is recorded at more than 10 hectares. Try to picture that honestly. 10 hectares is an area larger than 14 football pitches, and across all of it, there is one ant population. Not thousands of competing colonies. One, no borders inside it, no territorial fighting, no rival queens to slow anything down, because every nest in that 10 hectares treats every other nest as family. Lift a piece of rotting wood at one end, and you are looking at the same animal you would find under a paving slab 400 meters away. At the advancing edge, it does not creep, it arrives. Foraging columns push into new ground in numbers that make the soil surface look like it is moving, and behind them, the nests fill in the leaf litter, in the debris pile, in the cracks under the fence line. Native ants at that edge do not negotiate. They are simply overrun and gone. And with them go the seed dispersal, and the scavenging, and the soil turnover, and the predation on other insects that tropical ant communities quietly run. Colombian sources describe the species as a direct cause of displacement and loss of native biodiversity in the places it spreads into. Then, the farms. And here the failure becomes almost too neat to be true. The ant was brought in partly to protect crops. What it did instead was take up guard duty for the insects eating them. Fulva farms aphids and whiteflies for the sugar they excrete, and farming means protecting. It patrols the colonies of sap-sucking pests on stems and leaf undersides, drives off the ladybirds and lacewings and parasitic wasps that would normally hold those pests down, and in return, it milks them. The aphids and whiteflies, defended, multiply. They drain the plant and they carry disease between plants. Yields fall. Read that sequence again. An insect introduced as a crop guardian became the crop pest's bodyguard, and it did it for sugar. Then the livestock, and this is where the paperwork stops being abstract. Colombian environmental guidance states plainly that this ant's consumption of protein from the mucous membranes of domestic and wild vertebrates has made it a threat to livestock production. That sentence is doing a lot of quiet work. What it describes is a penned animal, tethered or fenced, or simply too heavy and too slow, standing over ground that has become the surface of a super colony. The ants come up the legs, they go where the skin is thin and wet, because that is where the protein is accessible. The eyes, the nostrils, the mouth, the udder. An animal in a field can walk away from a lot of things. It cannot walk off its own ground when the ground is the problem, and it has no way to reach its own face. So it stamps and it rubs against posts, and it stops feeding properly. And it does that again the next day and the day after, because the colony is not a passing event. The colony lives there now. Over weeks that turns into weight loss, chronic eye damage, and stock that will not settle anywhere near the worst ground. Farmers in infested districts learn to read it before they could name the cause. Poultry take it worse. A hen has no defense at all for a clutch of newly hatched chicks against a ground-based swarm that finds them in the first hours of their lives, in the one place they cannot be moved from. Nesting boxes and brooding corners are warm, sheltered, and static, which is precisely the description of an ideal foraging target. And then, the houses. Fulva was already a household pest in Brazil before anyone put it on a truck, and it behaves identically in Colombia. It nests inside structures, in furniture, in stored clothing and stored food, in the boxes at the back of a room nobody opens. Residents in infested areas describe the same routine over and over, sweeping out drifts of dead workers and frass that accumulate indoors day after day, from a colony that is not in the house so much as the house is in the colony. Sealing a wall achieves nothing. The nest inside was only ever a suburb of something much larger outside it, which raises the only question left. Can it be removed? The answer is unpleasant. Chemical control against this species has been tested extensively and performs badly. Repellency and efficacy trials found that no insecticide fully repelled it. Very few products delivered rapid knockdown at all. The best performers took roughly 13 to 19 days to reach full mortality under bioassay conditions, which is an eternity when surviving queens elsewhere in the super colony are producing replacement workers the entire time. Reviews of tramp ant control conclude that chemical approaches show poor success and short residual effect while generating environmental side effects of their own, and that current thinking has shifted toward hunting for natural enemies from the ant's original range, which is, if you follow it all the way through, the same idea that started this. Introduce something to fix the thing you introduced. The island that tried it and won, briefly. Colombia is not an isolated case, and the most instructive comparison is one where the predator actually worked. In the early 20th century, on the Adriatic island of Millimetres off the Croatian coast, authorities faced a genuine problem with horned vipers, one of Europe's most dangerous snakes. The solution was the small Indian mongoose, an animal with a global reputation as a snake killer. It was released around 1910. Unlike the ants, it delivered. Viper numbers on Millimetres fell substantially over the following decades. Encounters became rare. Assessed on its stated objective at the 30-year mark, the program would have been filed as a clean success and written up as a model. The problem arrived after the success. A generalist predator that has eaten through the easiest available prey does not starve politely. It switches. The mongoose moved on to ground-nesting birds, then eggs, then small mammals, then lizards and amphibians, and it kept going because there was no snake population left to occupy it, and nothing on the island equipped to hold it in check. Island species evolve without mammalian predators and have no answers to one. Elliot solved a snakebite problem and acquired a permanent biodiversity problem in exchange. Put the two cases side by side, and the lesson gets sharper than either one alone. Colombia's ant failed at its target and became invasive. Emilet's mongoose succeeded at its target and became invasive. The invasion was not a consequence of the program failing, it was a consequence of the program happening. So, which mistake was actually the biggest one? The biggest mistake ranked. There are 3 candidate errors in the Colombian episode, and they are not equal in weight. It is worth being explicit about the ranking because the biggest one is not the obvious one. Third place goes to picking the wrong agent. Nelandaria fulva was never going to control snakes. A generalist swarming ant cannot reliably reach concealed clutches, cannot touch live-bearing species at the vulnerable stage, and cannot handle adults at all. A serious look at the target's life history would have shown that the mortality this ant could inflict fell nowhere near the level needed to bend a population curve. That was a scientific misjudgment, and it wasted the effort. It did not, on its own, damage the country. Second place goes to ignoring the agent's own record. This information was not hidden. The Brazilian source material recommending fulva against otta and snakes described it as a household pest in Brazilian homes in the same body of literature. The recommendation and the warning arrived together. The program took the half it wanted. Everything the ant later did in Colombia, entering houses, farming honeydew producers, feeding on vertebrate mucous membranes, erasing native ants, was consistent with behavior already documented in its native range. Nothing it did was a surprise. It was a prediction nobody bothered to make. But the biggest mistake was neither of those. And it is the one that would still have mattered even if the snake control had worked perfectly. It was releasing a self-replicating, self-transporting organism with no way to take it back. That error has no floor. A failed insecticide cost you a season. A failed introduction of something that forms borderless multi-queen super colonies, nests in rubbish, rides agricultural and construction traffic across borders, and shrugs off every chemical thrown at it is not a failed experiment at all. It is a permanent addition to the region, and it compounds. 50 years on, that ant is in Cordoba, in the Caribbean, in Panama, and across the southern United States, outcompeting the fire ant on its own ground. Boyaca in the 1970s did not merely fail to solve Colombia's snake problem. It contributed a species to a global invasion, and there is no version of the next 50 years in which that is undone. Rank it that way, and this stops being a story about ants. What actually works? The modern approach inverted the entire premise, and the inversion is the useful part. Biological control still exists, and it is heavily regulated now. Candidate agents go through years of host specificity testing, quarantine evaluation, and non-target risk assessment before release is even discussed, precisely because of cases like this one. Even then, uncertainty is treated as permanent rather than solvable. But snakebite is no longer approached as an ecology problem to be engineered. It is approached as a public health problem to be managed, and the interventions are unglamorous and effective. Clear vegetation and debris around houses and work sites, which removes shelter. Store timber off the ground and away from buildings. Control rodents, which removes the food supply that concentrates snakes near people. Wear boots and gloves, because most bites land on hands and feet. Train communities in first response. And above all, get anti-venom close enough to matter, which is exactly what Colombia's National Institute of Health facility exists to do. None of that reduces the snake population. That is the point. It reduces the intersection. And there is a hard ecological reason not to want the snakes gone anyway. They are the rodent control. Remove them and you get more rodents, more crop loss, more damage to stored grain, and more rodent-borne disease, which is a worse public health outcome than the one you set out to treat. One more objection deserves airing, and it runs in Colombia's favor rather than against it. Introduced biological control has produced genuine, durable successes, including in Colombia itself, where Rhodolia cardinalis against cottony cushion scale has held up for over 75 years. It would be wrong to conclude from the hormiga loca that the whole method is worthless. The distinction that matters is specificity. Rhodolia is a specialist that eats essentially one thing and cannot survive without it, so its failure mode is self-limiting. Fulva eats sugar, insects, and vertebrate tissue, nests in rubbish, and needs nothing in particular, so its failure mode has no limit at all. The question was never whether to use biological control. The question was whether the agent's failure had a ceiling. The ant answered that. The reddish-brown insect released in Boyaca did not fight Colombia's snakes to a standstill. It did not lose to them either. It ignored them, walked past the job it was hired for, and went to work on everything else. The native ants, the aphid colonies, the chickens, the livestock, the houses, and eventually the countries next door and the continent above. Colombia still records roughly 5,600 snakebite cases a year. It still runs its own anti-venom plant. And it now also has a permanent invasive ant, with public advisories written about it, and infestations measured in hectares. The predator was never the mistake. The mistake was the belief that a rainforest is a machine with a broken part, and that the part could be swapped out by someone who had only read half the manual. So here's the question worth arguing about in the comments. Put yourself in Boyaca in the 1970s, with only what was known then. Brazilian reports saying this ant destroys leafcutter colonies and takes snakes. A discipline with real successes behind it, including one of the best in the world. Thousands of snakebite cases a year. No better option on the table. Would you have signed the release order? And if you would have refused, what exactly is the one thing you would have demanded to see first? Leave that in the comments, and if you got something out of this one, a like and a subscribe genuinely help.